Hello again, welcome to Magnetic Fields. This should be the last one in the series, looking at just some more applications. And the first one is quite a major one that is a major use of magnetic fields, and it's MRI scanning or magnetic resonance imaging, which is now commonplace in just about every hospital around the world. It basically relies on some high-powered physics and some very good maths, but basically it's a way of looking at soft tissues in the humans or any object. And before MRI, people were limited to using X-rays, but X-rays are good at showing solid things like teeth and bones, but not so good at looking at muscles and intestines and brains. And so MRI was developed, and there's also a competing technology called CAT scanning, which is a way of using X-rays, but MRI relies on magnetic resonance. So how does it work? Well, I'm going to give you a whole lot of words here and I'll try and summarize it, but you can read it, pause it and have a read. I'll tell you when it's all appeared. Basically, the human body is made up of billions of atoms, and a lot of them are hydrogen atoms because we have a lot of water, and every atom spins, and it spins around an axis, and that spin may be like this, okay, or it may be like this with a combined spinning as well. So it's sort of like a top spinning around its axis. And what we can do is, if we put hydrogen atoms into a magnetic fields, the hydrogen atoms will pretty much line up in the direction of the magnetic field. Well, most of them will, but some of them won't. Only a small fraction, but because we've got so many hydrogen atoms in us, only a small fraction, like a millionth, of the atoms don't line up, and they're the ones that cause the resonance to occur. And so if you have someone lying on their back in the scanner, usually the hydrogen atoms will line up from head to foot. Okay, now some will point towards the head, some will point towards the feet, and they will effectively cancel each other out. It's just a random process of them lining themselves up to the magnetic field. However, some out of every million will not cancel each other out, so there'll be a slight imbalance between the ones pointing to the heads and the one pointing to the feet, and so they're the ones that produce the effect of this percussion. And so what happens is, like here's our atom spinning, and it's also spinning around an axis itself. This is just another diagram saying the same. So that's our proton. It's spinning, but it's also spinning around an axis. And when we apply a large magnetic field, we get some pointing towards the feet and some pointing towards the head, but they don't all cancel each other out. So here we have 5, and here we have 6, and so there's a slight imbalance. And when we turn off the magnetic field, these guys all go back to the way they were, and that sort of gives us the image, or the release of energy that's not being cancelled out. So if you want to read that, pause it now, okay, and I'll just move on. Here again, lots of words, so you can pause that. So what happens is that when all these hydrogens are all lined up and cancelling each other out nearly, the MRI machine sends out a radio frequency pulse, and that pulse is specifically tuned to the hydrogen atom, and it causes the protons to absorb that amount of energy, and causes them to vibrate. And then when the pulse is turned off, that causes a release of that energy and gives us the variation in basically the variation in the abundance of hydrogen atoms, and that variation in the abundance of hydrogen atoms is then used to define different tissues. which is not a bad way of looking at it, because the brain contains less water than muscle, which contains less water than blood vessels, and so forth. And so what happens is these hydrogen atoms, when you turn off the pulse, they go back to their natural alignment and they release their stored energy, the energy that they got from being in a magnetic field. And so what happens is all this information is sent back and picked up by the coils, and they do a bit of maths and they come up with the image. And what do they look like? Well, that's an MRI machine. This is great big rotating or magnetic superconductor magnets and coils, and most of the noise you hear from these machines is actually the refrigeration, keep them cool, because they operate at very low temperatures to increase their sensitivity. And this little tray goes inside as well, and the person sits inside, and there's a variety of coils, some producing the magnetic field, some producing the radio signal, and some receiving the radio frequency. And this is a sort of slice of image that you can get, and you can see the detail of the soft tissue, including the eyes and things, and you get slices, and these nowadays with computers, all these slices can be put together into three-dimensional images. And so you can see, so in video 1 it's just called MRI. That will tell you how they basically work, and then because we're interested in magnetic fields, what would happen if you put a lump of metal inside an MRI machine? Well, there's a video showing you, not to be recommended. So there's also MRI 2, which details how MRIs work, and also what to expect when you get an MRI, and some of us may have had MRIs. There's a safety video. There's what happens when people, basically this one, MRI versus oxygen bottle, that's what happens when people are decommissioning these machines. Sometimes they have a little bit of fun and they video it, although nowadays occupational health and safety will probably stop you. And then in Japan they do special things with MRI scanners, so have a look at that video just to see what they do with a multi-million-dollar medical instrument. So they're on the OneNote. Now for toys, you get these levitating toys. Basically they're just using magnetic fields to cause them to levitate without any attachments, so they're pretty neat and people are amazed by them, but we should understand how they work. This is a little top that levitates. Back to biomagnetism, I mentioned turtles. They use an internal compass. They have a compass inside them that can actually feel the Earth's magnetic field, and they use that to navigate. And this was always a bit of a mystery, how turtles can return back to the same beach that they were hatched on, even after an interval of 30 years when they haven't been back to that beach. They will come back, and so they must be able to navigate somehow, and people have discovered that they use an internal compass. And the way they discovered that is they get themselves a turtle, put it in a tank, tie a harness onto it, and then let it swim. And then they have a coil around this tank, and they can change the magnetic field. And if they change the magnetic field, they then observe where the turtle swims, and if it changes direction, they correlate that to the direction of the magnetic field from the coil, and then they change it again, and they verify that the turtle is actually swimming in that direction. Then it's released back into the nature, of course. And that's what they look like. They're only held for a short period of time and then returned back to the ocean. And this is what the apparatus looked like. So there's the tub, and this is a coil, because they needed to also cancel the Earth's magnetic field. So they sort of used a whole lot of coils to cancel it. So they only had one magnetic field, and that was the one they were inducing. What have I got here? Look, there's a video. That's what it was. And these are some of the tracks that they take. The turtles swimming between America and the west coast of Africa. So that's slightly crunched up. It's quite significantly larger distances. And we have turtles in the Pacific that do similar, swim around the oceans and then come back to exactly the same beach, and they use Earth's magnetic field. Now, interestingly, what's cows got to do with magnetic fields? Well, someone found, they were looking at Google Earth images, and they noticed that cows in fields seem to be all lined up, and so they did a study. They looked at over 8,000 images from Google Earth that contain cows, and they correlated the fact that the direction that the cows were aligned. So looking at the Google map, they would go that one's, whoop, that one, that one, that one, that one. So they'd look at the alignment of the cows relative to the Earth's magnetic field, and of course not all cows line up, and they did this thousands of times, and then looked at the data, and they found that the cows have a tendency to line up north-south, and therefore how do the cows do that? They must have some sense of where north-south is. People don't really understand why they do that, but they just seem to do it. There you go. Geophysics, always looking at the Earth's magnetic field. This is a typical magnetic field sensor going over sites. It's very good for finding sites that have had intense burning, because the ash, or where the fire was, or might be somewhere where a ritual has occurred, that high temperatures cause a variation in the rocks just below the fire, and that can be picked up as a variation in the Earth's magnetic field. And so these guys move around with their backpacks trying to find that buried underneath the ground. And you can put them on poles as well. There's even a magnetometer on the moon, because people were interested in the Earth's magnetic, the moon's magnetic field, sorry, and that's still up there. And they wanted to know if there was much variation in the moon's magnetic field, and so that's been recording data for some period of time. Now, magnetic shoes. What do you think would have the use of magnetic fields? Well, here you go. Magnetic fields to deliver proven fatigue and pain relief through boosted circulation. I like this, as worn by Australian players. Now, who would use magnetic shoes? Bowls, people that bowl, and this is what they look like. And generally, if you took a random sample of lawn bowl players, they're pretty old and they all have aches and pains, and so they're trying to convince people to pay extra for these shoes because they've got magnets in them, and they do all that stuff. Magnets are also sold as wristbands. There was a famous wristband just recently that all the athletes used to wear, and was supposed to boost their performance, and so even super fit people can believe this. For old people, it's supposed to line up the blood flow in that area, and people have magnets. You can get pillowcases with magnets in it, and bedspreads and under bed blankets and all sorts of things with magnets in it. Pretty much all of it relies on what's called the placebo effect, which is a very strong effect where if people want to believe something, they can convince themselves that it's working, and therefore they feel better about it. So not much science behind any of those. This is an interesting question. Some of you have credit cards with magnetic swipes, and sometimes they don't work, and so people wrap them up in plastic and then swipe them again and they work. This little band here is recording stripes of magnetism, and the little swipe card is a magnetic field reader. And ATM machines rely on that, although they're being replaced with little chips inside the cards. But there's case of credit card skimming, and that's when people put a fake front to an ATM machine. People walk up to it thinking it's a real ATM machine, and it is. Slide the card in and it gets skimmed, and so this records the magnetic data, and then they also have a camera that they either hide on the ATM or nearby, and that records the PIN, and then they come back, take the skimmer off, which has the magnetic data, and then they use the video to get the PIN number, and away they go. They can steal all your money in the account, and that's happened in the London Underground ticket machines, where people use their cards to pay for train tickets, and numerous cases also happened in Australia. And there's also these skimmers, which if people in shops have been known to have, and so you hand over your credit card to pay for something, your credit card disappears below the table, gets skimmed, and then given back to you, and then later this data is used to open up all your accounts and take all your money out. And so generally speaking, most people advise you never to lose sight of your credit card. Not a big issue, fairly random things, has been known to happen in Australia. There was recently an arrest of a few people who were skimming cards in a McDonald's. They were employed in McDonald's and they skimmed cards there, but they got caught. Magnetic Man. Is man magnetic? Well, this guy thinks he is. He's got all these pieces of metal stuck to him, including an iron which supports some bricks. Hopefully we recognise that's just using the surface tension between the skin and the fork. Much like some people can hang a spoon off their nose. Doesn't mean that they're magnetic. So that's pretty much the end of this. You should be able to do all those questions, and then we're just about ready to move on to electromagnetic induction. So, cheerio.